it.
But
And
then
you
you go up, not cancel out.
Rowdy.
Because these
So worksheet assignment 1, problem 23.
Yeah.
Mr.
I just need a moment and then I'll be right with you. Okay.
Yeah, I just got.
So you have 7/3 equals 14/9 plus n. So the first thing I just have to ask you is this isn't a math question. It's just a algebra question. What do we do?
Bless you.
It's a you minor flip it.
Yeah, and I mean that's huge that you know that because that's not really a mathy thing. You're not doing any math. You're just showing me that you know procedurally what to do. So that's huge. So yes, we're going to subtract 14/9. And then you're going to cross those out. And I sometimes people think I'm weird when I say this, but I would make a case that you haven't done anything yet. You haven't done any math, have you? You just understand the process. It's like a monkey C plus, monkey do minus kind of thing. So at this point in time, we're now ready to actually do math. I have my n equals, the problem is done. I just need to do the arithmetic. How do you subtract two fractions? It is. You got to make your bottoms the same. Right. So 21/9 minus 14/9 makes 7/9. You with me? Brad. And Tyler, you said number 1 on the new worksheet.
We're just, and I just thought, yeah.
Mhm.
But that's way easier.
I need to print myself another copy real quick because it's okay. I'm going to get a lot of questions, and because I don't have any more paper copies, I'm just going to print one real fast. Give me like 30 seconds. I'll be a more efficient teacher if I do
I
this.
asked one thing?
Not right this second because I have to complete one task. Okay.
Okay.
So let me complete this task, and then I'd
Okay.
love to give you.
So, what'd you get from
this
that?
real quick. So Tyler, your question was worksheet assignment number 2, problem number 1. So when you take a quiz next week, this will be categorized in my mind as one of the harder problems. Like I go into every quiz and I know already, unfortunately, which problems are going to cause the most trouble. And if a problem just like this makes it on there, I'm expecting a little bit of trouble, unfortunately. So we got to flex on this. This is where the notes come in handy. Like I said, if you have a fraction and you want to get rid of it, you have to ask yourself first, is it a plus a fraction or a minus a fraction? And it's not. It's a times fraction, right? And to kill times fractions, we have to use parentheses and multiply by the upside down. So we take the 4 and the 5 and we flip them over like this. That's why I'm always amazed when people don't make a page of notes. It's always like, that is amazing to me. Because then you have a resource to say, okay, when it's one of these, this is what I do, right? So now what we're going to do is we're going to cancel out the 5s over here and the 4s, and then we're done. The algebra portion of the problem is quite literally done. Problem's over. Now what you have to do is something that has nothing to do with me. It's what you learned 2 years ago, and that is how do you multiply two fractions together, right? Do you see that on the left side? You with me? Okay. So what do you see over there that's interesting to you on the left side? And I do see your hand. I'm just kind of focusing on the hand. Huh? Right. I'm just waiting for him since it was his question. You got to look for numbers from the top of the fraction problem and the bottom of the fraction problem that can be divided by the same amount. Do you see them? I can't hear you because there's ambient. Okay, that's going to be a little rough for me. Okay, what I need you to see is that the 5 and the 25 can both be divided, reduced by 5. That's really going to be something I expect of you, is that you see that. So a 5 and a 25 should stick out like a sore thumb.
That was not weird. On number 2, I did. Would it be right if I took 15 by both sides?
Uh,
Do you need?
are you on problem number 2?
Yes.
Yeah,
Would it be right if I
add
add 15 to
Add
both sides?
15. Yep.
Okay, and then when it comes to the 24 and 15, I add those together or
You don't. So
I divide and multiply them.
I'll be with you in just a moment. Okay. I have to answer, not even listening. So the math problem you're going to do is negative 24 plus 15. I'm not copying the whole problem.
No, you're good. I
This
just
is what the math looks like. And what I need you to think about is, so at some point in your life, someone, bless their heart, probably taught you some rule about if it's this, then do this, and then add the sign of this. And I years ago learned that what's more important, like for you, was to be an intelligent adult who doesn't get ripped off, an intelligent adult who understands how your bank account works. All those things are predicated on the idea of just, I need you to understand numbers. So here it goes. You ready? Negative 24 means you owe Cooper $24. Are we clear?
if you add the 15 to
That
that's
means you
-9.
paid him back 15. Yep. And so you -9. A mistake I see a lot, Seth, is that people they try to like go, yeah, or they say something like, oh, that's -39 because they add the numbers and put a negative on it. It's just ridiculous. So always think about money. A negative is I owe somebody money, a plus is paid them back. And if you pay back
Yeah.
more,
It's just like a credit card.
it
Yeah,
is.
because I would have way, if I didn't ask, I would have way overthought that and went two different.
Imagine I switched their roles. Imagine you owe Cooper $15.
I paid him 4.
You paid him 24.
That would be positive.
Positive. It would be he'd say, hey, you gave me too much. He'd give you 9 back, right? Presumably. So yeah, makes sense.
Yeah.
Okay, so we're doing problem 7.
Okay, you're good.
Is that correct? No problem. So if anyone's interested, this is assignment number 2, problem number 7. If you want to come along for the ride.
I would like to, but I'm not.
Right.
Oh, also, I'm going to say this on the recording. Someone asked the other day, I think it was you, is it okay if my problems are out of order? And the answer is, of course it is, because a lot of times on days like today, like you might right now be on problem 3, but then you look up at the board and go, oh, maybe I should work on problem 7. That's fine. Like what I'm interested in is someday if I ever have to look at your homework, like you turn it in for a retake, what I ask of you is that it's neat and that the problems are ordered. The problems are numbered. So like, I don't care if your paper goes 1, 4, 3, 5, 6, 7, 11, 10, 9, as long as the numbers are there so that I can verify that they're all done. Okay. So don't worry about like, oh my God, I'd like to do number 7 with you, but I'm only on number 3. It's okay. Fractions again. Yeah, so this is going to be a pretty hot topic, right? The fractions. So we have 31 over 56 is equivalent to 31 over 8 times k. So it's the exact same conversation I had with Tyler. What's our approach to this? Let's say again, we multiply, right? And again, we're doing division. We're just skipping a step of the division, since with division, we'd have to flip it back over and copy dot flop it anyways. So that's why we shortcut it and just do parentheses and we multiply by the flippy flop of this guy. So we're going to flippy flop him into 8 over 31. And we're going to multiply him on both sides like this. You with me still? Now what's going to happen is we're going to do the easy part, cancel the 8s and cancel the 31s. And before you begin actually doing math, remember to lay the foundation. Get your variable, get your equals, get it ready, and now we math. There's a lot of good math we can do. Like what?
We should reduce.
Yeah, like if you were to multiply this out right now, you'd get 248 over like some insanely big number. No one wants to reduce that. So again, reduce while you can. So what do you see that we can reduce? Sure. Yeah, I'm surprised you took I thought you might go for the lower hanging fruit, but good for you. Right. But hey, let's do the hard one first. I'm in. So you said let's take these and let's divide them both by 8 because we can, right? 8 divided by 8 leaves a 1. 56 divided by 8 leaves a 7. And then you save the treat for last. You just go, haha, suckers, kill those 31s. And what's left? Done.
Those actually, you made, why do you make it so much easier sounding on the board, but when it goes to your head, it's like so complicated. And then you do it and it's like, when I'm really slow on that one.
I have a question.
Sure.
Number 3.
On the new worksheet?
Yeah.
Sure. So for anyone interested, this is today's new worksheet, worksheet 2, problem number 3. And imagine my surprise to see yet another fraction. This one isn't so much a fraction as it is a division, but still, it's got the same vibe. So, we got to kill the 4. And before you can kill a number, you have to identify what kind it is.
Positive.
That's it. I always know that question comes out wrong. When I say that, I don't mean positive or negative. I mean, is it a plus, a minus, a times, or divide? What is that for?
We need to kill the 4 with multiplication.
Well, that's a divide 4, right? But if we want to kill a divide 4, how will we do it? With multiplication. So job 1 is identify like what your target is and what kind of mathy thing it is so that you can do the right tool to undo the mathy thing, right? Monkey see plus, monkey do minus, monkey see times, monkey do divide. Like we can just literally train ourselves like that. So we're going to parenthesize the whole equation and multiply because our mission is to kill a divide.
And then the 4.
These are called inverse operations, by the way. I don't like saying that because people think it's like really hard, but every operation in math has an inverse, like everything. So inverses cancel each other. So the times and the divide are inverse operations. And then we're done. We just drop down the M, we drop down the equals, and then we math.
What if it's 60?
4 times 15 is 60.
I was just overthinking.
That happens a lot.
Me
That is
too,
perfectly normal.
It looks so
Joseph, you're next, and then Embry's in line after that. So, yeah, for $1. Is it on the new one? Yeah, I had no idea how long it would take, but yes, you've made it to number 8, and I was 100% certain that I would go over this in every class today. So, yeah, let's do number 8. I almost deleted this one when I was making the worksheet. I thought, no, this is a good conversation piece for us. So let's do number 8. So assignment 2, problem number 8.
2 and 5, 6. Plus B equals 9/2.
One thing you'll learn, I'll tell you, but I mean, you're only going to learn it when you're really ready, is that, and it could be your sophomore year, your junior year, you could be a freshman in college sitting in some math class, and someday you're going to look at one of these guys and realize they suck. They suck. And I get that in like elementary school, they're like, Marcus needs 4.5 cups of, like, okay, fine. So they have use. I get that in the world, but in just the straight world of mathematics, mixed numbers, they suck. And so one piece of advice I can give you early on is just don't work with them. I don't mean like get hostile and get pouty. I mean, convert them into improper fractions. Trust me on this one. It helps a lot. And so the first thing I'm going to do is I'm going to take 2 and 5, 6. And it's always interesting to see when I meet a bunch of new 9th graders, how many of you know how to take a mixed number and turn it into a fraction? It seems like it's one of those things that's kind of started to go by the way of the dodo bird. You remember this process? You remember the process? You remember the process? You remember the process? Rad. What's step 1? Anyone just shout it out. That's it. And so Joseph, the algorithm says we're going to take 2 times 6, which is 12.
17.
And then we add the 5. Good. So apparently they are still teaching this, huh? So this is 17 over 6. And just take it from a guy who has not only been on this earth for a while, but has been working with teenagers doing this for a while. It's just advice. Mixed numbers, you ought to switch them because they're just way less of a pain. So I'm going to take this problem that Joseph asked me about, and I'm going to actually rewrite it. And instead of putting 2 and 5, 6 there, I'm going to put 17, 6. And that right away takes a lot of the bite off of this problem. I mean, it's still kind of poopy for people that really hate fractions, but it's way less poopy. So now, Joseph, the algebra question is, what do we do? And I understand why you say that, but again, I need to stress to you that just because you see a fraction doesn't mean put parentheses and multiply. This plus sign is separating the fraction from the v. You're thinking, yeah, you're thinking of when they're stuck together. That's when we multiply to break it off. This is just a pluser, so we use a minuser. Like, you good? Okay, so we're going to do minus 17 over 6, and we're going to do it on both sides of the equal sign. And again, nothing to do with mathematics. I'm just going to do some housekeeping. I'm going to cross those off. I'm going to drop my variable and I'm going to drop my equal sign. Clear that landing zone so when you do the math, you can just plug it in and it looks good. So from yesterday, we had this conversation. How do you add or subtract fractions? What's the thing?
You have to have column.
Yeah, if the bottoms aren't the same, ain't going to happen. So what is the least common denominator of a 2 and a 6?
Would it be 6?
It would be 6. When I ask that question, I mean, what's a bottom that both of those fractions could be made to have? And what's nice is that the fraction on the bottom is like, I've already got a 6. Ask idiot boy over here to have his bottom become a 6, and then I'll talk to him, right? And so what we do is we take the top fraction and we say, we got to cater to the boy below. So we're going to take the 2 and say, I can make you a 6. But if we do that, the trade-off is whatever we did to make the 2 into a 6, we have to do to the top, right?
So it would be 18?
Nope. 2 times what makes 6? 2 times 3. So if you times 3 the bottom, you got to times 3 the top. And what is 9 por 3? 27. See. At
You
this,
put 27.
did I?
You said 26.
I said 26.
You said, I
Did I,
didn't say 26.
did I say 26?
Yes, you said 26 and I put 27. Did you mean 27?
In Spanish, you said 26.
Okay, so my Spanish was good, but my English I messed up.
Yes.
That's one confusing one.
That's a first. Anyhow, regardless, Joseph, it is definitely 27 over 6 minus 17 over 6. And now that the bottoms are the same, I know my answer is going to have the same bottom. 27 minus 17 is 10. And tienes que reducir la fracción. Puedes
Five
dividir los
thirds.
dos números por 2. 5 sobre 3. Done. But you see, again, the key there, what busted us wide open was that we took that evil mixed number and said, I'm going to make you a fraction. Yeah, good. Rad. Who's next in the queue? Embry. 11 on again, today's worksheet. Yeah, no problem. So assignment 2, problem number 11. Hey, look at that. It has a fraction in it. So we have -1 equals variable minus 1 1/3. I would recommend you take the same advice as I gave you last time. I got to be honest, if I were doing this problem on my own. So I'm just going to, since it's your question, I'm going to talk to you. Well, first off, do you know the algebra? Do you know what to do? What are you going to do? Oh, okay. But I meant like, let's say we didn't do that. Let's say I just gave you you're going to add 1 1/3. So I don't know you yet since we just met a few days ago. I don't know what your math skills, how strong they are. Do you know what -1 plus 1 1/3 is? Not to put you on the spot. I'm just curious. If you owed me $1, that's -1, right? If you paid me 1 1/3, did you cover your debt or do you still owe me money?
You've covered your debt.
You covered your debt. And how much would I owe you back?
A third.
A third. So if you wanted to approach this problem from a simple perspective, you could honestly, these are easy numbers, you could just tackle it, but I'm going to do what you said because you're awesome. So you said, let's turn this evil mixed number into a fraction. So you said, let's do 1 times 3 plus 1, and that turns the mixed number into 4/3. We okay? Now what are we going to do? You're going to add 4/3 to both sides. and we're ready. So at this point, again, make fractions. That's, I can't stress enough. If a problem involves fractions, make everybody a fraction. Fractions are like anyone coming into the party, you better be a fraction. So -1's like, fine. Do you guys all know how to make -1 into a fraction?
Put a 1 under it.
I could make it -1/1. Hey, could I make it -10/10?
No.
Sure, I could. Could I make it -46/46?
Yeah.
Okay, how about this one? Could I make it like, I don't know, something crazy like -3/3?
Yes.
Okay, so here's the deal. The number 1 is like a chameleon. He could be whatever he wants. And there will be times in your math life where you just make 1 into crazy stuff because it fits the mold. In this case, Embry, I want to take this -1 up here and I'm going to rewrite it as -3/3. And of all these fractions, I could have done -8/8. I could have done negative Embry over Embry. I mean, I could do, sorry, that's really ridiculous. But the point is, I could do negative happy face over happy face, right? I could do this all day. I could pick anything over itself because we all know that that equals 1, right? But I picked this one. Why? Why? Is it because I love the number 3?
It's
Because I want it to be the same as the
common
one on the bottom,
denominator.
right? I said the denominator on the bottom is 3, so I got to cater to that guy. And that's why I chose negative. If the bottom fraction had like a 7 as the bottom, I'd have said -7/7.
1/3.
Be whatever I want it to be. And there you go. So now we know the answer has a 3 on the bottom, right?
1/3.
And it's 1/3. -3 plus 4.
Love you, Mr. Anchor.
Rad, got it? Rowdy, I guess you're next. What's up?
14.
On today's very last one. Imagine my astonishment to see that this problem has fractions in it. Say what?
Wouldn't you just add 5?
It's on the other page. So I can give you a second, but I got to get back to the other page.
Mr. Ahern, a question on number 18. Would it be adding 5/2 to each side, or would it flip and multiply?
We'll talk about this. It is a flip multiply problem.
I thought
Yeah.
so.
Ready?
Yeah.
This is going to be the big question. And I've already seen it. I'm going to see it again in 6th hour. I'm going to see it again in 7th hour. A lot of us are of the mindset that all fraction problems, I just do them the same. And I hope we're starting to figure out that that's not true, right? We've learned that sometimes a fraction needs to be added or subtracted away. And we've also learned that sometimes a fraction needs to be multiplied to be destroyed. Your job as a student now is to start understanding which is which. How do I get rid of that?
You divide. It's pretty simple, Rowdy. We already did it on the other one. It's fairly simple.
I don't know that that's necessarily productive or constructive, but I think what he's trying to say is don't overthink this. Whenever there's a fraction attached, and I mean literally attached, because this implies right here multiplication.
Yeah.
And when it, yeah, but again, please refer back to what we've practiced. Don't divide by a fraction on purpose. Times by the flippy flop. Yes, 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 yes. So this is a times, and we're going to flip it, but you have to keep it as a negative when you flip it because I want the negatives to cancel just like the 5 and the 2.
Yep.
So we're going to flip it and call it -2/5.
Okay.
Now, the beauty, Rowdy, is that over here on the right-hand side, the negatives cancel, the 5s cancel, the 2s cancel, and the problem is over. The algebra part of it.
Reduce.
Now, let's talk about this red and white side over here, the red and white. What's the first thing you notice for me? It has nothing to do with numbers. What do you see? I'll give you a hint. Times another equals a. So the first thing a smart person would do is just ignore the negatives because knowing in the end that they're just going to go away, don't burden yourself. Good. Now let's talk numbers. What do you see that you can reduce?
The 2 and the 4.
Let's do it. 2 gets divided by 2, 4 gets divided by 2. Awesome. Anything else?
Not that I can think of.
Me either. 43 is just kind of messing up the whole program here. So at this point, we just suck it up and say, there's nothing else I can do. So we multiply across the top, everyone that's alive, multiply across the bottom. And you can say this with confidence. If I've reduced all the parts and pieces possible before I multiply, I'll never have to reduce after I multiply, which is pretty rad. What do you get on top?
43.
What do you get on bottom?
10.
And you are done.
Thank you.
No problem.